Okay, guys, let us start. First of all, okay, I guess you can hear now. You can see my screen, yeah.
Yeah, we can see your screen.
Okay, okay, okay. So let's start. Okay, today we're gonna continue the first part, or maybe the second part of the kinetics section of in our curriculum. Okay, so we were moving to sheet number 8, which is talking about the kinetics regarding the normal and tangential components. Okay, if you remember the last week, or we have passing through the kinetics, but for the motion, or the rectilinear motion, a motion in a straight line, and we defined the motion in two axes, which were the x-axis or and the y-axis. Okay, so I guess now, guys, please could you mute your microphone, please? Yeah. Okay, so we will pass through from the rectilinear motion going to the curvilinear motion. Okay, and when we are talking about the curvilinear motion, give me 1 second. Let's need to check. Okay. Uh, when we were talking about the first of all, the last week, we were talking about the rectilinear motion, and this rectilinear motion we define, as we said before, two directions, and we studied the summation forces in x and summation forces in y. Okay, now we will go to the curvilinear motion, and in this section we will, in this video, will not talk about any curvilinear motion. We'll just talk about circular motion. So we will always talking about the circular motion. The particle always moving in a circular path. Okay, when we're dealing with circular motion, we have two cases: horizontal motion, okay, like we are moving in a horizontal circular plane motion, and this one have been cancelled from the syllabus. Okay, and the second one is vertical motion, and again it's a circular motion. So this one, the one who we're gonna study during this video. Okay, okay, so let's start from the basics. Now remember, when we are talking about this one, we're talking about un and ut, and this un and ut is when we are moving for a circular path, you'll define two components. The first component is un, is from the point, and towards its direction is towards the center of the circle, and the second one is perpendicular, okay, and it's tangent to the circular in the direction of motion. Okay, so we have two unit vectors. The first one, which is the unit vector normal, which is pointing from the point or the particle toward the center, and the second one is that tangential, which is perpendicular to the normal and tangent to the circular path in the direction of the motion. Okay, let us just to have a quick review for the kinematics. If you remember that during the circular motion, or sorry, during the normal tangential motion, we will always having like a movable axis. So if the particle is moving on the surface for the point 1, we will have, if this is the center, you will have this is un and this is ut if it's moving downward. And for point number 2, this will have a un and this will have a ut. Okay, and what you'll find that the origin will be always coincide on the particle, so we will have like a moving origin. Okay, and the first thing we need to introduce in the kinematics is, if you remember, the position vector, which is the position vector of any particle minus the, sorry, it is only the position vector, and it's measured from the particle to the origin. So if we have this origin and we have this particle, this were r. Yeah, okay, so here we didn't have an origin, we didn't have a fixed origin, we have a movable one which is always coinciding the particle. So in this case we couldn't have a special expression for the position vector, and we shall say that this one is not applicable while we are using the normal and tangential components during the kinematics. So in this whole video we'll not hear a single word about the position, and we only use two other main components of the kinematics, which is the velocity and the acceleration. The first one is the velocity, and the velocity is a vector which is the speed or the magnitude of the velocity in the ut or the tangential component. And again, this is a velocity, it's only in the tangential component, because as we have introduced before, the ut, it's what in the direction of the motion. So the total component or the total velocity is in the ut, and we have no component in the second direction, which is the un. Back to the acceleration. The acceleration is to have two components. The first one is at is equal to, or a is equal to at ut plus an un. And at is dv by dt, and an is v squared over rho. Okay, but if you remember, just give me a second to allow the others to enter with this. Okay, back again. If you remember that we have another expression for the at, which was v dv by ds. Yeah, okay, and since you know that ds is equal to r d theta, and why we are saying this, because back again we are talking about a circular motion, and this circular motion have like a center, and this is a part of a radius of a circle, sorry, this one, the solid line. Okay, so is this an incremental distance on the circular path, and this will be an incremental d theta, and again the length of any arc is equal to r theta, so the length of an increment of an arc will be equal r d theta. Okay, so at will be simply v over r dv by d theta, and this is a third form for the at, and an will be the same always, which is v squared over rho, and we could say that this rho is equal to r, because we are moving on a constant circle, so rho is always constant with a constant radius. Okay, so we will find that this at is equal to v over r dv by d theta, and that's new expression, and this en is at the same before v squared over rho. And here we will find that the 80 is the direction of increase of motion. Sorry, it's not the direction of direction of increase of motion. An is direction towards the center. Okay, so this is the expression. I could say not this increase of theta, this is the direction of motion. The second one was a theta. Okay. Okay, so before I shall continue to the second part, I just need to be sure that all of you have got this point. And the only thing that is very important here is to define that 80 is equal to v over r dv by d theta, and an is equal to v squared over rho. So if it's clear, we're gonna to move to the second part. If you have any question, please ask.
Yes, sir. I didn't understand like why n equal to v square by rho.
Okay. Why you understand this?
I didn't understand why n equal to v square by rho.
Yeah, well, okay. Mizan is talking, yeah? I guess.
Yes, sir. Yes.
Yes. But then this one is have like a proof, okay? But we'll not cover it in this video, okay? So I could pass you a written proof, okay? Why an is equal to v squared over rho, okay? But it will not be covered, and it's not needed from your side. It's not included. We'll not ask you in this part, okay? So yeah,
No problem, sir.
yeah.
Why like no? I don't wanna like the proof of this formula. Can you just please tell me like why v square by rho? Then you equal then you just write equal v square by r. So just
Yeah. The last one, okay. V squared over rho. If you remember, rho, this was the radius of curvature, and this one was changing by the path. But here we are talking about a circular motion, so the radius of curvature will always be constant, which is equal to r, the radius of the circle. Okay, so it's clear now.
yes, sir.
Yeah. So the general formula was when rho was variable according to where the particle is moving on this curve. Here we are talking about a circular path, and the circle is always have a constant radius, so we could replace rho with an r. Yeah. Good. You got it, Mizan?
Yes, sir. Yes, sir.
Okay, very good. Any other questions? Okay, no problem. Okay, the second part here that we are moving from the kinematics, and we have a quick review of the kinematics, and now we are just need to move to the kinetics part, which is the part that we are focusing on today. Okay. Give me 1 second, please. Okay. Okay, so basically the kinetics is not more than that you are saying that the summation forces in each direction is equal to the m in the acceleration corresponding in this direction. Okay, so simply, if you are like here, if you are going to zoom in, if you have summation forces in the t direction, which is the tangential direction, is equal to mat. So the summation force is equal to m, and again we will use this expression. Okay, so it's mv over r dv by d theta, and this will be our first equation. The second one was the summation fn, which will be equal to man, and again it's equal to mv squared over r, and we have said before why we are replacing rho with an r, and with this will be the second equation. So we have only two equations, okay, to solve. Okay, the steps is very simple and clear, okay, and will be repetitive in all of in all of our problems. The first step is to find the summation ft equal m over time at, and here you will find that you could find the function v function of theta. Again, you will find from this one, and we will show you how to get it during we solve these problems. But the first or the main important thing that you must come out when you are solving equation number 1 is to when we integrate equation number 1 we will find v function of theta. Okay, so now if you know v is function of theta, so you could get at any theta the velocity, or let's say the speed, and when you get at any theta the speed, you will get at any theta at, and you will get at any theta an. Okay, so from here, if after we get v function of theta, so it means that we have got an correspondingly, so m summation fn equal m to an, which will be equal mv squared over rho. Now we will have the v, so we will have if any forces in the normal direction is unknown, and it could be, and it will be, might be in the normal forces, which is the T, tension in a rod, normal reaction. We could solve this equation to get this to T or the normal reaction. If it's not clear now, it will gonna be clear during we're solving these problems. So basically, I just need from you to be to just ensure that you know how to get that, or you know how to that the summation ft is equal m80, and m80 is v over r dv by d theta, and summation fn is equal man, which is equal to mv squared over rho, and you only have two unknowns, and we two equation, and we will only solve these two equations. Okay, this two notes will be clear when we are solving our questions. Okay, so after we have introduced what is the kinematics, and again what the kinematics, we only need two expressions. This is the first one and the second one. What is the at and what is the an? And the second we have passing through the kinetics, and we just need to know to something. The first one is the equation of the summation ft, and the second one is the equation in the u and direction. Now we just need to divide our problems into two main problems. The first one, let's say it's constrained, and second one is unconstrained. Okay, what is the difference between constrained and unconstrained? The constrained, that you are having a particle that it's moving during a circular track, and it will never ever it will never ever leave this path under any condition. How could it done? Is like that we are moving a particle in a solid tube, and this particle, it will always be in the solid tube. This solid tube, the particle will always be in this one and will never leave the tube. Okay, the particle could be moved, could stop, but it will never leave the tube. Okay, this one is called the constraint function. The second form of this tube is like to have a particle moving like that. It is like you have a particle moving like around an arm, and I don't know what is could be in English, but this one is particle moving in a circular track, and the particle is attached to this circular track always through its middle. It's like it's passing through the middle. This one is typically like this one, so they are the same. Okay, why we are saying that we have two types, which is the first one is constrained, the second one is the unconstrained, and we have now knew the constrained one. Why we are studying this one? We are studying this one that we have in the problem. He will say find the minimum velocity, or the minimum initial velocity that you need to give to the particle in order to complete a whole cycle. And why I'm saying that in order to complete a whole cycle in the constraint condition, we just need to translate this one into a condition that v must be greater than or equal 0 at the height point. Okay, why this? Because if the v is here greater than or equal 0, and again v is a velocity, and it's a speed, after it's if its ray barely reaches point, just moment after it reaches point, it would fall again under the gravity, because here we are talking about the vertical circular tracks. Okay, so it will move again by the gravity. Okay, and will complete one cycle. So if I am having a particle moving from this point and I give it the minimum velocity to reach this point, it will definitely go back again to the initial position. Okay, okay. What the difference between the constraint and the unconstrained? The unconstrained is the particle could leave the circular path. How it could be done? There is no any constraint that the particle must be in a circular path. It could leave it. Okay. The first one, if we have a circle track like this, if I'm having the circle track like this, and this is a particle, and this particle is moving, I have give an initial position like that, the particle will move up, move up, move up, move up. We have two conditions to end this circular motion. The first one, if the particle leaves the track, if the particle was there and then it go down like this, free fall, it couldn't reach the top. Okay, or the second one is the particle couldn't reach this velocity like the previous one, didn't was sufficient to make the particle reach to the highest point. So we have two conditions. The first one, that the velocity is greater than zero, and the second one is the particle didn't leave the circle track. And how we could translate the didn't leave? When we say that any particle didn't leave a circle track, well, in other words, we could say that the particle have a contact with the surface. Okay, and if we are saying that the particle have a contact, if I have a contact, I could say in other words that I have n or normal reaction must exist. So we have this mean that n should be greater than or equal 0. Okay, so in the unconstrained we have two conditions. The first one is n is greater than 0. Okay, at any point, or at any point, and again it depends on if n will be the minimum at this point. Okay, and v greater than or equal 0 at the highest point again. So we have two conditions to check, while the first one we only have one condition to check. The particle could leave the circular path. We have three examples. The first one is the cable, and the cable, if I'm moving a circle like that, okay, and give it an initial position, if I don't have a sufficient initial position, you will find that this particle will move to this point, and at this point you will find that the cable attached to the particle might be loose. So if the cable will be loosened, which is mean there is no tension, again this particle will leave the circle path. Okay, so here if we have the cable, it's unconstrained condition. Okay, if I'm moving move on a circular track like this one, okay, from the outside it's an unconstrained condition, and if it's moving from the inside, it's the unconstrained condition like this one. So I hope it's clear. For the second one, it would never complete a whole cycle. Okay, will never, because at this point surely it will leave the circle due to the gravity. Okay, so for these three cases they call the unconstrained condition. And to wrap it up, we have two conditions. The first one is constrained, and this one that we are very sure that the particle will not never leave the path at any condition, and this one could be a tube, could be a rod, and there is a difference between a rod and a cable. A rod will not be loosened at any time, so it will move always in a circular track. And if we need to ensure to complete one cycle, we just need to ensure that the v is greater than or equal 0 at the highest point. We only have one condition to check, while on the other one, which are the unconstrained, the particle could, which means that the particle could leave the circular path at a point, at any point, like for example a cable moving in a circular track or moving inside a circular track. We have two conditions. The first one is that the particle does not leave the path, and this means that we have We just need to have and ensure there is a contact between the particle and the bus, which is mean that the n is greater than or equal to 0, and n is the normal reaction, and let's say n or t, okay, if we are dealing with a cable. And the second one is that like the same is to ensure that the velocity at the maximum point is greater than 0. Guys, I guess this one was tricky, so I'm waiting for a lot of questions, so please ask if you have one. What the three condition? The whole? Why waziri? Okay. Okay, waziri. Okay, again, we are talking about. I will try to make it short again. We are talking about simply between two different conditions. The first one is constraint and unconstrained. What is the difference? The difference is a very little thing. Is he will ask me to find the minimum initial condition in order to this particle could complete a whole cycle. And what the meaning of the whole cycle? The particle reached the point which started from. Yeah, Waziri?
Yes, sir.
Yes, okay. If I'm talking about a constraint like a ball is moving in the tube, so the it's simply if the particle is having a speed at the highest point, it will go more. If it's equal to 0, it will move back to the initial position under the gravity. So the minimum velocity is needed when you have v greater than 0 at the highest point. This one is clear or not? Yeah. For the second one, we have two conditions that the particle will not leave will leave the or end the circular motion. The first one is like the same. At the highest point, the velocity is greater than the 0. Okay, but let's say this case, especially this case, if I ensure that the velocity here, I said to you that the velocity is greater than 0. Yeah, I have said to you this velocity is greater than 0. Do you ensure to me that this particle didn't leave the circular track? I'm asking you, Azir.
Now?
Yeah, I'm asking you. If this now this is a particle, this is moving inside the tube, okay, inside the circular path, and I'm saying for you that I'm ensured to you that it's 100% that the particle will have a velocity greater than 0 at the highest point. My question to you, do you totally 100% sure that this particle will complete one cycle, one whole cycle?
Yes, sir.
Why?
Because you ensured to me that it has a 100% velocity.
No, but what about if you here the particle I'm solving, like this particle is moving up, but at this position, let me make it with the green one. At this position, n was equal to negative. Do you understand what is n is equal to negative? While I'm moving on this one, always the particle is trying to going downward, yeah?
Yeah.
It's going to going like this, trying to move outside the circle, So n always will be in this direction. So this is n, this is n, and will be this n, this is n, yeah?
Yes.
Okay, if I'm moving like that, and this is the particle, and you'll find n is a negative, so it will just oppose its direction, yeah? So n will be in this direction. Okay?
Yes, sir.
So when n is in this direction, do you have anything that prevent the particle to move from this position inside the circle and leave the circular path?
No.
No constraints. Yes?
Yes.
So I have to condition is to ensure that the n or the t, if I'm dealing with a cable, have a value greater than 0, and the v is have a value greater than 0. So it's clear now?
Yes, sir.
Yeah.
Very
Okay.
clear. Thank you very much.
Okay, Wazir. Okay. So guys, it's clear for all of you?
Yes, sir, it's clear.
Okay. Okay. So just to have a quick look of what we have already speak about, we have passing through the kinematics. Again, kinematics V is equal to V times ut, and A have two components, V over R dV by d theta, and An is equal to V squared over rho. Okay. And again, for the kinetics, we have summation f of t and summation f of n, which is equal mv over r dv by d theta, and mv squared over r for the fn. And we have introduced two types of problems. The very difference is the difference is very little, and it's for only the condition if you ask it about what is the minimum velocity shall the particle have in order to complete one cycle. For the constraint one, we have only one condition, oh sorry, to check, and for the unconstrained one, we have two conditions to check. Okay, so everything is clear now.
Yes, sir.
Yeah, very good.
Yes, sir.
Okay, let us start to solve the first question. And the first question is, we have a roller coaster, and this roller coaster track down in a container in a vertical plane, and again we only deal with the vertical plane. The portion of the track between A and B is straight and horizontal, so it's a straight one. Okay, while the portion to the left of A and to the right and B have a radii of curvature as indicated, and this is a circular path. So the first one is rho is equal to 30, and the second one is rho equal to 45. Okay, a car is traveling at a speed is equal to 72 km per hour when the brakes are suddenly applied, causing the wheel to car to slide on a track, and mu k is equal to a quarter. Determine the initial acceleration of the car if it brakes applied. If the brakes are applied, the car almost at reach A is traveling between A and C just past B. Okay, so we are going to divide this region into three region. The first one is before this one, the second one is between A and B, and the third one, this is 1, this is 2, and this is 3. Okay, so uh, the first thing is to let us start with just before the first case, just before A. Okay, um, the first thing is to draw your free body diagram. At point A, you will find that you have an horizontal surface. Okay, this is a horizontal surface. So this is point A. This is weight. We have a contact with the track, so this is the normal, and this is the friction force. All of this is equivalent to, if this point A, to two components. The first one, again, he's asking just before A. So A, here we are moving on a circular one. It's a horizontal, but it's a circle, okay? So like this, as if I am at the bottom of the circle. It's horizontal, but we are still in a circular one. So we have two directions to study. The first one is from the particle to the center, which is un. Sorry, this is un. And the second one is in the direction of motion, so this is ut. Okay, so you will have this passes, you have m un, and you will have m, sorry, an, and you will have m at. Okay, this how is our free body diagram. The first thing is to apply the two conditions. So let's start with summation fn. Summation fn saying that n is equal to minus mg equal to m v squared over r. Okay, so from this point you'll find that I didn't get the the n which is equal to a certain number. Just get an expression. N is equal to mg plus m v squared over r, while for summation ft you will find that minus mu k times n. And why minus mu k times n? Because this we are removing, so it's equal to minus mu k times n is equal to m at, and you'll find that minus mu k times n, which is equal to mg plus mv squared over rho, is equal to MAT. What we need, we need to determine the initial deceleration if the brakes are applied. So what is the deceleration? We have two components. What is AT and AN? I'm asking you what he's seeking for. He's seeking for AT or AN or A? No, the answer is he's seeking from the AT, because AT is the one who is responsible for the decreasing of the speed. Again, we have two components. The first one is AT, which is responsible for the change of speed, and AN is responsible for the change of the direction. So you're just asking about the rate, the initial deceleration, how the part will slow. Okay, so it's only asking about AT. Okay, so back again, let us substitute. We have 0.25, and we have m, which is equal to, you give me m or no? Give me 1 second. Okay, we could just eliminate m from the whole equation. We have m here, and m there, so we could eliminate it. Okay, and g is a constant, and v, he's moving with v equal 72 kilometer per hour, and we are not dealing with kilometer per hour, we're dealing with the metric units, so it will be equal to 72 times 5 over 18, which will be equal to 20, I guess 20 meter per second. So this is 20 squared, and r here were equal to 30. Everything is okay, so you'll find 80 is equal to negative 5.78 meter per second squared. And why it's negative? Because we are decelerating. Okay, if you are asking about not the deceleration, the total acceleration, okay, the total acceleration will be equal to square root 80 squared plus an squared, and we have got the 80 already. An is equal to v squared over rho, which is 20 squared over 30, so it's equal to 40 over 3. This is the an. Okay, if you were asking about the total acceleration, yeah? Okay. Okay, let's go to the second part. This is first one with just before a. What? Yeah?
So here is only simple question, like sir, in the last part, how you will get an equal to like u square by 3?
Yeah, just like equal v squared over rho. 3 is 20 squared over 30, which is equal to 40 over 3. Yeah, that's okay. 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 The second part is, let's have the green one. We'll get the magenta. Yeah. The sport from A to B, and this one is a straight line. Okay. So let's start with our free body diagram. Again, I will zoom out in order to see this one. Okay. Okay, so we'll have, again, this is M, this is N, and this is friction force. All of this is equivalent to, sorry, in the direction. Oh yeah, it was right. MEX. Okay. Why? Here I'm just at the point A again. Yani, I'm studying at the point A again. What the difference between at the point A just before and the point A just after? The difference that we're moving on a circular track, and now we are moving on a straight line. If you are moving on a straight line, v squared over rho, for any straight line, the radius of a curvature tends to the infinity. Okay, so rho or the ray r, let's say it's equal to infinity. So an, which is v squared over rho, v squared, any number of or any value over an infinity will lead to 0. Okay, and I guess it sounds okay, because when we have just stated that the an is corresponding for the change of the direction of the velocity, not the speed of the velocity. The one who are responsible for the change of the velocity is the speed is 80, while the one who is responsible for the change of the direction is en. Yeah, and we are moving on a straight line, so there is no change in the direction of the velocity. Yeah, the velocity is always in the direction of the straight line, so we will have v squared is an again is equal to 0. Yeah, so one could just write an, and another could maybe say it's mat. Both are okay, nothing is different. Okay, okay, so from this one you will find that in the summation of f t, let's say t, to have a consistency in the samples, so ft will you find that fr, which is mu k, sorry, yeah, mu k times n is equal to mat, and from the summation of summation fn you will find that n is equal to mg. So this one, from this one you'll find that minus mu k times mg is equal to mat. Again substitute, you'll find this is equal to 0.25, and you should cancel the m with an m, so 80 will be equal to 2.4 negative 2.45 meter per second square. So just before we go to the third part, which is B, is it clear what the difference between the first one and the second one, and we have why we got two components in the first one, and when we got only one component in the second one? Here I was talking about the acceleration, two components for the acceleration, and the second one we have only one component for the acceleration, and we have cancelled the second one. So it's clear, or there is any questions? I guess Muhammad was raising his hand.
Yeah, I have a question.
Yeah, please ask.
First of all, when we're drawing this free body diagram,
Yeah.
both have wheels and both have frictional reaction, why are we not having any other quantity, right?
Why we don't have?
Why we don't have any other
Yeah,
force?
because there is no force. He's only. Do you see any force to the right?
No, 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 no. We don't have.
Yeah. So, type. Okay, and let ask me your question in other words. Why this particle is moving to the right, and we have no force to the right? Yeah.
Yeah, 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 right.
Yes, this one is your question. Yeah. So if you are driving your car, okay, and now you are moving with a speed which is equal to 100 kilometers per hour, and you just press your brakes, do you have any driving force in the direction of your motion? No. The opposite. You are trying to stop the car, so you have kind of force in the opposite direction. Okay. what which is make you moving in still moving to the right is your initial velocity. Okay, you are still having a velocity and you're trying to stop it. Okay, so it's not moving in you have no forces in the direction of motion, you have forces in the opposite direction of motion trying to stopping this particle. And if you find you just see that the 80, which again it's which is responsible for the change of the speed or the magnitude of the velocity is equal to negative, which is mean that yes, I'm starting with 72 kilometer per hour, but now I am decelerating, and at point A I'm having a velocity which is less than it's negative 72 per hour, and I'm having at point B a velocity which is less than the one at the point A. Yeah, so it's clear now.
Yeah, very clear.
Okay, very good.
Just another thing, sorry.
Wow, ask please.
So after so if I remember, I'll ask.
Okay, please ask again. Okay. Type. Okay. The last one is just past B, and if you just last B, you will find yourself it's similar to the A. So let's solve it. There's only one difference between A and B. Uh, I'll try to solve it. Let's say in blue one and this one. Just this is K3. Just after B. And again, if I'm moving just after B, again now I'm moving on a circular path, and you will find yourself that this one is you'll find yourself that this one again on a circular track, and the circular track you have two components, not three components. Okay. Okay, so not one component. Sorry. Type. But this is point B, and I will draw the forces, and again I have only this friction force, and I have normal, and I have mg. This one is equivalent to this is mat, and I'm using the right one because it is the direction of motion. The particle is still moving in the right direction, but you'll find that I will swap the direction of man from the up to the down. And why I'm doing that? Because at point A, the center of, let's keep it in red as A, you'll find this center will be at the up. So again, man or an direction is in the direction of the point toward the center. In blue one, you will find that this is at point B, the center is to downward. So I'm putting I'm putting an to the down instead of the up. So it's clear what the difference. Why I'm putting the first one. This is ut, but this is un. Why I'm just having like a mirror for un. Why I'm just having un. The first one was for the upper, and the second one is was for down. Yeah, it's clear.
Yeah, it's clear. It's clear.
Yeah. Okay. So if it's one is clear, the next steps will be systematic. So again, summation Fn is equal to n minus mg, but this is one. This will be negative n plus mg. Why? Because downward is a positive, is equal to mv squared over r, and this one is summation ft, which is equal to again negative mu k times n equal to mat, and again you will find that negative mu k times n, which is now is equal to mg plus mv squared over rho, or r is equal to mat. Okay, so again substitute, this one is equal to 0.25, we should cancel all the m. Okay, and you find that the v is equal to, what is the term of the v? How we could get the v?
We cannot continue to use 72.
Yeah, I will get the v.
I think we just use 72. 72. 72 times the power.
Yeah, let me check. Give me 1 second. If the 72 is up. No, I guess it's equal to MAT is equal to AT is equal to N minus MG. This is V naught. Okay, I guess yes, it will be 72. Okay, so it will be the same as previous. So this will be 20 squared. Yeah, and let me check if we have finished the session. If I have this one is not correct, I will resend it to you. But I guess it's now it's same. Okay, 72. Yeah.
Yes, but
Yes.
I think we're supposed to have M minus MV and MV squared over R.
No. Because I'm here, we have n. Yes, it's negative. Yes. Very good. Yes. Mg minus mv squared over rho. Yes, it's correct. Okay. So it's clear. Yeah, it's correct. Yeah, I have just checked. Yes, correct. So the very difference between just before A and just after A is we have changing the direction of the UT, which will correspondingly change in the first equation, which is this one. You'll find here n is equal to mg plus mv squared, while here n is equal to mg minus mv squared over rho. So clear?
Yeah, it's clear. Just one question.
Yeah, please ask.
If at every point that we have AN and AT.
Yeah. At every point, if you are moving on a circular track.
Okay,
But
understood.
if you are moving on a straight line, an will be 0, will vanish.
Okay. But if it is on a circular, you have AT and AN. If it's on a straight
Yes.
line, AN will
Yes.
be 0.
Yes. If I'm saying that I'm moving with a constant speed, at is equal to 0. So constant speed, at is equal to 0. Moving in a straight line, an is equal to 0. Constant speed and moving on a straight line both means that the total acceleration is equal to 0.
Okay.
Okay.
Understood.
Okay. Let's go to the second questions. Okay. This second question is saying that we have a ball of a mass m move in a smooth circle, but again, smooth is mean we have no friction in a vertical plane. The ball will start its motion at the initial velocity u, and u is not given when theta is equal to 60. Draw the free body diagram in terms of theta. Write the equation of motion in the tangential and normal direction. If the velocity u is in the acceleration, let's move from A and B and then see what he needs for C and D. Okay, the first one is basically what we do in any problem is to draw the free body diagram. Okay, this is the center of the circle, and he just defined this is theta. Yes.
Yes.
Okay, I'm gonna choose any arbitrary position. Let's say that this particle is at this point. Okay, sorry, at this point, sorry, like he's drawing. Okay,
Can't we choose any point?
any point, just any point. Okay, so if this is any point, which mean, or this is now the point that we are studying. Yeah.
Yeah,
Okay, and again this was theta. Yes. Okay, and what I have is this. I have this is mg. Okay.
yes, sir.
Okay, if do you want anybody see any forces rather than the weight force?
I think so. AT and AN.
No, no, that is مثلا the AT and AN is not an external force. This one is in the yeah, the inertial one. Okay, for the external force it's only mg. Yeah, but we need to define two direction. Where is the ut and where is the un? Okay, so ut is in the direction of motion tangent to the surface, which is this is ut. Yeah,
Yes, yes.
and un is perpendicular to the surface toward the center. So I have now introduced my two directions. Okay, mg is in the direction of any of these two unit vectors.
I don't think so.
So we need to resolute.
We need to resolute.
Yes, yes. So this is in the ut direction, and this is in the un direction. And by vertical opposite angle VOA, you will find that this is theta again. Yeah.
Yes, sure.
So this is mg cosine theta, and this is mg sine theta. And guys, we have a mistake here, me and you. We have just forget that we have a normal reaction. Yes.
Exactly, that's
Yeah.
right.
Yes. So we have here normal reaction. Okay, and I guess all of the force and normal reaction from its name, it's in the normal direction. Okay, one say it's. Do you know it's in the it's in this direction or the opposite? It's moving away from the circle or toward the circle. Here we are moving in a loop, so we don't know. So and if it's come positive, it's good. If it's come negative, it's good also. If we are dealing with unconstrained one and is equal to negative, it's not good because this means that we leave the surface. Okay, so and here it don't. It's not matter where we put its direction. Okay.
Okay.
Yes. Okay. So this is equivalent to this is the particle m at and m and like Mizan said before. Yeah. Okay. If you remember, we said that we just need to begin with, if you find this question, just need to start with summation ft. Okay, summation ft will use is equal to, and the ft is equal to m g sine theta equal to m at, and this at were equal to v over r dv by d theta. So I will rewrite this equation, but first I will cancel m. So g sine theta will be equal to v over r v dv by d theta. Okay, so I will separate the variables. At the site I will have g or sine theta d theta is equal to v dv. And this I have a typo. This is SV over R dv by d theta. Okay. So okay, I have all of the theta in one direction and all of the v's in other direction. So simply I'm gonna to integrate. Okay. Guys, okay or not?
Yeah, you integrate.
Yes.
Yeah.
Okay, if you integrate g and r is a constant, so you'll find yourself saying that v squared over 2 is equal to negative g r
Ah,
cosine
theta.
theta and plus c. Okay, I will move to the left, so you'll find that v squared equal to negative 2gr cosine theta plus c. Yeah. Okay, how to get the theta? He said that it's a velocity, its motion was initial velocity u when theta is equal to 60. So at theta equal to 60, v was equal to u, not 0, u. Yeah.
Okay.
Okay. So u squared is equal to negative gr cosine 60 plus c. Okay, and cosine 60, so we'll find that v squared is equal to negative 2 gr cosine theta minus 2 gr cosine 60. So I'll just simplify, but v squared is equal to negative is equal to, sorry, this is u squared, c is again is equal to, sorry, c is equal to u squared plus 2gr cosine 60. So v squared is equal to negative 2gr cosine, sorry, is equal to negative 2gr cosine theta plus c, which is u squared plus 2gr cosine 60. Just again simplify this one, you'll find this is equal to 2gr, sorry, u squared, v squared is equal to u squared plus 2gr cosine 60 minus cosine theta, and we know all that the cosine 60 is equal to half, so we'll find that the v squared is equal to 2gr u squared, sorry, plus 2gr half minus cosine theta. Okay.
I'm confused.
Okay, again, at v squared is equal to negative gr cosine 60 plus c. This one from the integration, okay? And we know that the initial condition was theta is equal to 60, v is equal to u. U is simple. Okay, so I'm just substitute with then at u at theta is equal to 60, so u squared is equal to negative gr cosine 60. Yeah, because at theta equal to 60, v is equal to u. So c is equal to u squared plus 2gr cosine 60. Back again, I'm substituting with c in the initial, in the main equation, the original one. So v squared is equal to negative rg cosine theta plus c, which is equal plus u squared plus 2gr cosine 60. So v squared is equal to u squared, this is u squared, not v, u squared, okay, plus 2gr. I'm having a common factor, 2gr cosine 60 minus cosine theta. Okay, cosine 60 is half, so v squared is equal u squared plus 2gr half minus cosine theta. It's like a simplify. If you don't have time to simplify it, just put it in this form. This is a good one. V squared equal negative 2gr cosine theta plus u squared plus 2gr cosine 60. No problem at all. Okay?
Yeah. My first question here is how do we know that v is how did we get v is equal to u?
Yeah, he said this. He said that it starts its initial velocity u.
Oh, okay, okay.
ماشي. Okay, طيب. Back to the second equation. This one with the first equation. So the second equation is, let's divide it. Summation fn is equal to, summation fn is equal to mg cosine theta minus n is equal to m an. Yes?
Yes, yes, yes.
And an is equal to v squared over rho. So you'll find yourself writing that n is equal to mg cosine theta minus m v squared over r. Yeah?
Yes.
And from this equation you'll find that mg cosine theta minus m time over r times r, which is u squared plus 2gr times, and again let's keep it in, n will be equal mg cosine theta minus m over r v squared plus 2gr half minus cosine theta. And this is n. Yeah?
Yes, yes.
Yes, okay. So, okay. Now I have two equations. The first one is v in terms of theta. So if I know the initial position and I know the theta, I will find the initial velocity, and at any theta I will find the velocity. If I find the velocity, I will simply find n, because n is equal mg cosine theta minus mv squared over r. Yeah? Okay. So let's go to the third requirement. If velocity u, he gave me here u, is equal to root gr over 4. So u squared is equal to gr over 4. Yes?
Yes.
Find the velocity of the ball and the normal reaction as it reaches the lowest point. Lowest point, this is the lowest point. Yes?
Okay.
So lowest point mean theta is equal to what?
0.
No, no, no. Remember, this was theta. Theta we were measuring from this point. This is theta. So theta will be equal to 180. How? This is the lowest point. This is the lowest point. And I am measuring from this point. So theta will be this one. Yes?
Please, how do you know that you're supposed to stop there?
Because he stayed at the lowest point. And this is the lowest point.
The lowest point means like
Mean the lowest point. The lowest point, guys. Lowest point is the lowest point.
you said lowest point is the lowest point.
But yeah, where is the lowest point in this track?
Yeah,
Okay, so again I now know the theta, so from equation 1 you will find that v squared, which is the one he need, is equal to u squared. U squared is equal to what?
U squared is
Gr over 4, yes, plus 2gr half minus cosine 180, which is equal to 13 over 4 gr. Okay,
yes, yes, yes.
and n were equal to mg cosine theta minus mv squared over r. So it will be equal to mg cosine 180 minus m time v squared over r. This is r, so it's time equal 13 over 4 gr. So this will be equal to negative 17 over r mg. Okay.
Okay, yeah.
Okay, going to the last one, and this is find the minimum value for you to make a complete revolution. Okay, and this one is constraint type or non-constraint?
I think it's non-constraint.
It's constrained. It's typical.
I think the first one.
Yes, it's typically like this one. Typically, yes.
Okay, yes, 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 yes.
Okay, so this one is constraint. Yeah. Okay, so when we have constraint, we just need to check only one condition. V is greater than 0. Guys, give me 1 second, please. نعم يا فرح.
لازم امشي كلب وانا وعليا تحت عشان انا نزلتها عشان الكلب قاعد يشمشم كتير فنزلتها خايفه تدخل لوحدها.
ماشي. Sorry, guys. Okay, so again, we just need to have only one condition, that V is greater than 0 at the highest point. Okay. Okay.
Okay, sir.
Okay. So we are still in question 7. So D is to find. I'll make it in another color. Let's do it in blue. Is to find minimum V to have complete revolution. And this means that V should be greater than or equal 0 at theta, or let's not say at theta, at highest point. And what is the highest point have theta equal to? This is the highest point, yeah? Yes?
Yes.
Yeah.
So theta at this one is equal to is equal to, rather than two values, equal to 0. Let one say 0, and the other could say it's equal to 360. Yes?
360 is complete.
Yes. Yes, that is a complete cycle. So let's make it 360 to make it more convenient. So theta is equal to 360. And again, we just need to check for one condition, which is V. So V squared is equal to U squared, and I'm again writing the equation, 2gr half minus cosine theta. And let's substitute. We are now solving V is equal to 0. This is the minimum condition, so this 0 squared is equal to U squared, where this is the one we are looking for, plus 2gr half minus cosine 0 or 360. You have only one unknown, which is u squared in terms of r, surely. So you'll find that the u squared should be greater than or equal gr, and the minimum u is greater than or equal root squared gr. Okay, this is the minimum initial velocity that the particle could start with in order to have a complete cycle. So, um, guys, it's clear or not?
I think after finishing the class, you will give us this answer or like in a sheet or something like that.
Yes, I will give you. Okay, but this one, you have this one which is completely solved. Okay.
Yes, sir. Yes.
Okay. Okay. Let's go to the question number 8. Okay.
Please, I have a question.
Yeah, please ask. And question 7.
In my, I want to ask, mg normally, mg is acting downwards.
Why mg is acting downward?
No, I know mg is acting downwards. I know mg is acting downwards, but normal, is it not supposed to be acting opposite?
Okay, yeah. Now normal is in a negative sign, yeah? So it's acting normally. It's acting in the other direction. But since we are dealing with a constraint type, so there is no problem at all. Understood? Huh? The one who is asking. Yeah, yeah, you got it? Because n, we are in a constraint one, so it's not matter if it's positive or negative.
So what about when it is unconstrained?
Nice, and as constraint n equal to negative means that we didn't complete a cycle.
Okay.
Okay?
Yeah.
Yes.
Thank you.
Okay. Back to question number 8. Okay. For question number 8, he said that the ball of a mass m is attached to an inelastic rod. Inelastic rod, it's mean that it's be like it's inelastic. It's like a cable. Okay. So inelastic rod attached with a length L. If the ball is in a given initial velocity, again it's u from the initial position where the chord is horizontal. So we have an initial position where the chord were horizontal. So this is the initial position, the one I'm drawing with the red color. Okay, and again we are moving in a horizontal plane. If you know that the maximum allowable tension in the chord C maximum is equal Ag. So we have a new condition. If the tension is greater than 8 mg, now the chord will be broken, yeah? It will be cut. Okay? So we have again four requirements. The first two is to draw the free body diagram and to write the equation in the tangent and normal like the same. So let's begin with A and B, and then moving forward to C and D after we completed the free body diagram and the equation of motion. Okay.
Okay, sir.
So the first thing is to draw your equation of motion. Again, let's studying an arbitrary. So this is the point O, and this is our ball, and we're going to put all the forces. So we have here mg, and we have here t. Yes. And again, we just need to define our direction. So this is, if this the position of this, the arbitrary. So this is, sorry, this is in the direction of motion, so this is u t, and this is in the normal direction to the surface, so this is u n. So we have two directions. This is ut and this is u n. So we just need to resolute all the forces in these two directions. So again, where is theta? Theta is here, and this is theta. Just to write this one. This is theta. So this is theta. Okay. So I will resolute in these two direction. So this theta, this not theta, this theta. Okay. And you'll find yourself. Give me 1 second. Yes, this is. You'll find yourself have two forces. This is mg cosine theta, and this is mg sine theta. Okay, I just need to check how I got this theta. Again, theta, and with an alternative angle, this is theta, like z1. And since the ut is perpendicular to un, so we have perpendicular angle here. So theta plus this angle, let's say in x, is equal to 90, and again x plus this angle is equal to 90. So this is equal to theta. Okay, and just resoluted mg in the both direction with cosine and sine. Okay. Okay, this is equivalent to MEN and MAT. So everything is okay with the free body diagram?
Yeah,
Yes, okay.
it's okay.
Yes, let's move to the equation of motion. So we'll start with Ft, and Ft will give us that mg cosine theta is equal to MAT, and this MAT is equal to mg cosine theta equal to m v over r dv by d theta. Again, we will cancel both m together, and we will separate the variables. So we'll have gr cosine theta is equal to v dv. Sorry, and we have forgot d theta here. So this d theta is equal to v dv. So we shall integrate. Okay, from this one you will find that v squared over 2 is equal to g, sorry, negative, also yes, g, sorry, gr sine theta plus c, and I'm moving the 2 on the other side, so v squared is equal to gr sine theta, and 2c is constant times 2, it will remain a constant. Okay, so now we need to look for our initial position, our initial condition, sorry. We find that if the ball is given an initial velocity u, so the initial velocity is u from the initial position where the chord is horizontal. So I should translate this one into at the horizontal position, which is theta is equal to 0. You'll find v is equal to u. Okay, so again I'm u squared is equal to 2g r sine 0 plus c, and sine 0 c is 0, so you'll find that c is equal to u squared, and you find that the final equation will be v squared is equal to u squared plus 2g r sine theta. And this our first equation of motion. And again, v is in terms of the initial velocity and theta. Okay. Okay. Let's move to the second one, which is summation Fn. And summation Fn say that t minus mg sine theta is equal to m v squared over r. So t is equal to mg sine theta plus mv squared over r, which means that t is equal to mg sine theta plus m over r u squared plus 2g r sine theta. And next step is just to simplify, so it's not mandatory one. Just to make this one more simpler, it will be t is equal to m u squared over r plus 3 m g sine theta. And again, this step is not essential one. Yeah, and this is equation number 2, and we have just finished the first 2 requirements. So it's clear for you how we got equation number 1 and how we got equation number 2?
Yes, sir.
Yes, very good. Yes, very good, very good. Okay, back to C. And C is asking find the velocity of the ball and the tension inside the cord at okay, find the velocity of the ball and the tension. We have this one already. Okay. And what he's asking for, find the range of the velocity of u so that the ball can make a complete revolution and the cord will not cut. Boss. Okay. This one is very tricky, okay? Why? Because he gave me 2 conditions. The first one is we have complete revolution. Yes? The second one is cord will not cut. Yes? Okay. But this one is unconstrained. Why it's unconstrained? Because it's attached with a cable. Inelastic rod is a cable. So back to our papers, we will find that for the unconstrained we have 2 conditions. N or T must be greater than 0 and F must be greater than 0 at height point. Okay? So we have 2 conditions. Here we are dealing with T, not N. So we have 2 conditions. T must be greater than 0 and V must be greater than 0. Yes?
Yes, sir.
And cord will not cut. We have T maximum. This is the T maximum. So T must be less than or equal 8 mg. From this one we will get minimum U, and from this one we will get maximum U. Okay? Guys, clear? Shabab, guys.
Yes, sir. Yes, sir. Yes, sir.
Yes. Okay. Let's begin with the minimum U. Minimum U, let's start with V greater than 0. What is the critical point for V greater than 0? When at the highest point. Yes? And where is the highest point? at theta is equal to 270. Why 270? I started from this position and I measure theta from this position. This is the highest point. In red, this is the highest point. Yes? So I am moving like this. And the theta is equal to 270. Yes?
Yes, sir.
Okay, for this one, you will find that v squared equal again to u squared plus 2gr sine theta. Just substitute. You will find that 0, because we are looking for 0, is equal to u squared plus 2gr sine 270. And you'll find this u must be greater than or equal. Give me 1 second. Two gr. So the minimum velocity, in order to have a velocity is equal to 0 at the highest point, is u must be greater than 2gr. Okay? Okay, but again there is another condition we must check. Yes? Which is t must be greater than 0. But again at which point?
The highest point.
Yes, again at that point. Why at the highest point? We have 2 points of view. The first one is the physical one. Where is the most point, which is the critical point that I'm the most afraid that the cable will be loosened? If this one, let us imagine this is a particle when I have a ball at the end of the rope and I'm moving it, just giving it an initial position, which is my critical point that I must afraid of, that I will have no tension in the cable. I guess if you imagine the motion, you'll find when the particle is pointing at my cruiser is here. Yes? If it's here. Yes? This is the most critical point where you are afraid of that the cord will be loosened. Yes? There is no tension. Yes?
Yes, sir.
Okay. If you find yourself that you are not comfortable when you're dealing with physics, let us move to when you are dealing with mathematics. T is here function of the v and function of theta. Okay. Sorry, function of u and function of theta. U, I'm looking for u, so it's only function for theta. So the minimum term that will be for theta, okay, for sine theta, sorry, which is we mean that is a critical one, because if the sine theta will we have the minimum will have the minimum coefficient for the sine theta, so I must have a greater u. So you'll find that the minimum sine theta will be at negative 270. So again, if you're looking from the physical point of view or from the mathematical point of view, you will come to on one end that yeah, T maximum must be at the highest point. Yes. And guys, it's in most of the cases it's at the highest point. Okay. If you are dealing with if you are dealing with this case, it's at the highest point. T greater than 0 at highest point. If you are dealing with this one, n greater than 0 at highest point again. Okay. So again to our question, you will find that u, I need to zoom out, is equal to u squared over r plus 3mg sine theta so substitute 0 is equal to m u squared over r, because I'm looking for the minimum t, plus 3 mg sine 270, and you will find that the u must be greater than or equal. I need to check, is it u or u squared? Yes, this is u. I guess it's u squared, not u. U squared. This is u squared. And this is u squared. It's greater than or equal 3gr. Okay, so I just need to ask you one question. In order to have one complete revolution, the minimum u squared will be 2gr or 3gr?
3GR, sir.
Yes, because I'm moving with 2gr. Yes, I will ensure that I have v is greater than 0, but the rope will be loosened before I'm reaching the highest point. Okay, so this one is the one we are looking for. Okay, okay, going to the maximum one. You will find that the maximum one is again at t less than or equal 8 mg. But what I'm asking you is, where is the maximum t? Where the maximum t will happen?
Sir, I think at the lowest point.
Yes, it's at the lowest point. So maximum, this t is at lowest point. And the lowest point here, theta, was equal, this is again the lowest point, and I'm measuring from this one.
90 degrees, sir.
Yes, yes. So theta is equal to 90 degree. Yes. Okay, so again to the t equation, so t equal to m u squared over r plus 3m g sine theta. So if I'm substituting, I will put here tmg equal to m u squared, and I put max over r plus 3m g sine 90. Okay, you will find that u max is equal to 5 g r. Okay, so he was asking for, he's looking for the range of values of u. Okay, so again you'll find yourself that u is between square root 3gr, this is the one from the left side, to square root 5gr. So the only values that satisfy his condition is between these two values, 3gr and 5gr. Clear? Anybody has any question?
No, sir, please.
No, please explain the last part, the maximum u.
What?
The maximum u, please explain it.
Okay, the maximum u is t is greater than 8 mg. Yes, should be less, sorry, mg, because t maximum is equal to 8 mg, so t should be less than 8 mg. Yes?
Yes.
So t, where is the maximum t tension will happen? The maximum tension will happen at the lowest point.
Which is said to be 90.
Yes, which is said to be 90. So t is equal to mu squared over r plus 3 mg sine theta. This is from equation number 2. So again, t is equal to 8 mg, mu maximum. I just added the maximum in order to differentiate from another u. Okay. Over r plus 3 mg sine 90. And just substitute, you'll find that u squared maximum is equal to 5gr. So u maximum must be less than 5gr and must be greater than 3gr. So this is the range of the acceptable initial velocity. Okay? Any other questions? Okay, guys. Guys, for the last question, I just need to have يعني I will not just solve it completely. I will pass you the answer in the PDF, okay? But we'll just see if they have any another idea that doesn't cover during the previous one, or it's like the same, okay? So let's read it with yes, please.
Why don't you give us this one next try?
What?
Next class. You should try this one. Next class, to ask any question, I'm going to ask.
Okay, it's if it's good for all of you, just like an exercise. Okay, no problem. I will provide you the answer in any cases.
No problem. You are going to send me video, right?
Yes, yes, yes.
So we're going to take one question, inshallah.
Type. Okay, so this one will be treated like an exercise. Okay, no problem at all. Okay, just guys, I just need. Okay, I just need to ask you one question. I guess, and let us confirm as usual because I don't know. Okay, first of all, just need to stop our video.